The demonstration starts by opening the RAA tool that is integrated into Pupin SCADA EMS system. The dispatchers are opening the real-time part of the application, and then after that loading the most recent contingency analysis from the real-time. As you can see in the contingency violations, there is 3 lines that are potentially violated, and in base case there is only 1 line that is overloaded by 16%. The dispatchers are now checking the line to see what the load is made up of. So they are opening the substation Čačak 3 from where the line is starting. As you can see on the SCADA image, the line is overloaded and the current is blinking in red light. Also, the dispatchers are noticing that the line is overloaded mainly with reactive power. So they are deciding on which remedial action that they would take. The voltage on 100 kV level is around 115. So with their experience, they are now checking the other substation, that the substation Čačak 3 is connected with 110 kV network. So that's substation Požega, and the voltage there is around 113 kilowatts. So they are deciding that the best remedial actions would probably be to change the tap positions on the transformers in these 2 substations. The next step that dispatchers would take is that they would push the remedial actions that are already implemented in the system in the RAA tool. So when they load the remedial actions, you can see that the main remedial actions for this line are the change of the tap position. So the dispatchers are checking the 2 transformers that they decided to change the tap positions, and then they are sending the command to execute another power flow to validate their decisions. So the power flow is done automatically, and they are now checking the substation Čačak 3, where you can see that the load on the line between Čačak 1 and Čačak 3 is significantly reduced by changing the tap positions on these 2 transformers. They are now going to check the substation Požega as well, because there was a change in that substations, and they are looking for some other violation that could happen with changing the tap positions. As they look at the loading of the lines, they don't see anything that is overloaded, so they are deciding to apply those remedial actions. They are firstly going to need to enable SCADA commands before they confirm the RAA activation. That's one safety measure that is implemented into the RAA tool, so that the dispatchers wouldn't accidentally send the commands before they confirmed it and they decided that they are valid. So we are now looking at the SCADA image of substation Čačak 3 and the tap positions on the transformer that are going to reduce from 12 down to the tap position 6. the line is still overloaded, so there is some time that is needed for the positions in real time to go down, and we can observe it in substation Čačak 3. So now the position is at 10. They are going down 2 by 2. That is the SCADA representation of the field measurements. Some time is needed to transfer the data, so it goes a little bit slower, but as the positions go down, so does the loading on the line and also the voltage on substation level 110 kV. Now we have reached the final position, that is 6th position, and the load on the line has fallen to 322 amperes. And the megavars are reduced, as well as the voltage on substation level. Next picture is SCADA picture of substation Požega. So we will see that the tap positions on the transformer number 2 are going up, and they are at 9th position, and the voltage has risen to 115 kV, which is higher than we started with. So this remedial action was successful and the base case violation was solved. The demonstration continues by solving the N-1 contingency. So the dispatchers are firstly opening the RAA tool, and in real-time part of the RAA tool, they are loading the latest real-time contingency analysis. As shown on the video, there is no more base case violations, and there is 2 possible contingencies, both on 110 kV lines. The contingencies are sorted from the least, from the biggest one to the smallest. So the dispatchers are choosing the biggest contingency, which is the overload of 110 kV line between substation Belgrade 20 and Belgrade 3 for the disconnection of 400 kV line between substation Pančevo 2 and Čibuk. The overload would be 20% of the 110 kV line. As shown on the pictures, this is real-time SCADA image, and the dispatchers are checking the current load on the line, which is 662 amperes. The dispatchers are deciding that they would connect in parallel operation 2 substations, the 400 to 110 kV substation Belgrade 20 and 220 to 110 kV substation Belgrade 17. This will be done by switching on the 110 kV circuit breaker on the line in substation Belgrade 28. The line is connecting Belgrade 28 to substation Belgrade 20. With this switching, the dispatchers are hoping to alleviate the load from the 110 kV line between Belgrade 3 and Belgrade 20 and solve the contingencies. First, before switching, they would need to perform the analysis to confirm that there is no other overload that would happen with switching on of this line. So the dispatchers are now choosing the remedial action, that is switching on the circuit breaker in substation Belgrade 28, and then they are executing these remedial actions in the application called dispatcher power flow to check if there is some violation. This is done automatically. So the dispatchers are now choosing the substation Belgrade 20 and Belgrade 28 in the report of the analysis to see if there is some possible overload. The line is between Belgrade 28 and Belgrade 20 is connected and is loaded around of 70%. So that is the expected load, and there is no other overloads of any element. Before switching the element, dispatchers will open the SCADA image to monitor the switching process. So they would open the SCADA image of substation Belgrade 28, and after that in the RAA tool they will send the commands for switching on the circuit breaker. So the dispatchers are now finding the Belgrade 28 SCADA image. And after that, they are going to enable real-time SCADA commands. This is necessary to stop some mistake with sending the signals that are unwanted. So now the signal is sent, and in a few moments the circuit breaker would be closed in substation Belgrade 28. The load on the line is around 500 amperes. And in substation Belgrade 20, the dispatchers will observe if the load on the line is lesser than before. So we started with around 600 amperes, and after the remedial action, the load on the line is around 300 amperes. So the contingency is solved. Once again, to confirm that this contingency is solved, the dispatchers will load in RAA Tool the real-time contingency analysis that is performed after the switching on of the line, and the contingency that is related to this 110 kV line should disappear. So that is exactly what has happened. The only one contingency that is left is under 10%, so that is desirable, and there is no base case violations.